Hello and welcome back to another episode of A Key to 3.2. Is that what I call them? Or do I call them Key HWs? Oops, I forgot what I call them. Anyway, these are comparisons. I think I went over this in the how-to video. Foot is to boot, as hand is to glove. You figure out the relationship between the first two things and then figure out what would have that same relationship to that third thing, and you come up with the fourth thing. Pencil is to writing, as violin is to, well, what's the relationship between pencil and writing? Writing is what you do with a pencil. So what's the relationship between violin and blank? Well, blank is what you do with a violin. What do you do with a violin? Play. Playing. Playing music. Fishing is to lake. What's the relationship? Fishing, lakes are where you do that. Soccer is to blank. Where do you do that? A field or a pitch. If that's what they call it in England, a soccer pitch. Slope is to parallel lines, like same slope, it should say, really. As negative reciprocal, well, what's the relationship between parallel lines and slope? They have the same slope. That's what parallel lines have. Negative reciprocal is to what kind of lines? What kind of lines have negative reciprocality? Perpendicular. Hexagon is to triangle, as decagon is to, well, what's the relationship between hexagon and triangle? Well, this actually has multiple answers, I think, although you can make a hexagon out of triangles, but you can also make a decagon out of triangles. So that would be, the relationship is you make hexagons out of triangles, you make decagons out of triangles, so the answer is triangle, triangle. However, I don't think they really do that. I don't think these things, these types of statements, the answer is never the same as it was as the first relationship. So let's try something else. Triangles have three sides, hexagons have 6, 6, 3, 3 is half of 6. What's half of 10? Because decagon has 10, 5. Pentagon. That's probably a safe one, especially because kind of they're testing your knowledge of names of shapes. Subtraction is to addition as division is to blank. Well, addition is the opposite of subtraction. That's the relationship. So what is the opposite of division? Multiplication. Congruent is to shapes as equal is to blank. Congruent is to shapes can be congruent if they're the same, and numbers can be equal if they're the same. Decide if true. Provide a counterexample if it is false. An acute triangle only needs to have one acute angle. False. Now, I saw some people drawing acute triangles to prove this. No, you want to draw an obtuse triangle which has two acute angles but not acute triangle. I mean, it's a cute triangle, but it's not an acute triangle. Look at this little cute triangle, but it's an obtuse. If a rectangle is cut in half, there will be two triangles. Rectangle. Oh yeah, if you cut it in half like this, there'll be two triangles. But what if you cut it in half like this? False. That's making two trapezoids. If you have a supplementary angles, they will create a straight line. False. These are all false so far. For instance, let's just what supplementary? These are supplementary. Same side interior. Same side interior are supplementary. Oh, I wasn't on the screen. Oh no, that was my best little parallel line. But not along a line, not along a line making a line, right? These are supplementary. They make a line here. Here's the straight line. But not these two. They're making like a box. If you have a complementary angles, it will add up to 90 degrees. That's true. Finally give us a truey. Entity diagrams have a history and progression of the way they're created. For each diagram, list the steps in the order you think they occurred to make the diagram, then make a conjecture about the piece of the diagram indicated, considering using a compass and straight edge to no, I'm not going to reconstruct it. So, notice how 2 circles go through E. So to find E, you have to have those 2 circles. Now you might say, well, there's 2 circles that go through A. Yes, but there's a circle around A. So you can find A first, make a circle, then go out to C and D and make 2 more circles, and they will come back just like making a hexagon. The fact that there's no circle around E means there's no way to locate C and D from E, but there is a way to locate C and D from A. So A must have come first. Alternatively, you could have chosen this segment first and just made 2 circles around the ends. And then D, the reason why this line keeps going, I think, is because D came later, had to be marked. D had to be found based on this length. But at any rate, what's important here is that E came after these first 3 circles, and then you can't make DE and CE without E. So these 2 segments came lastest, most lastest, no matter, guaranteed. Those came lastest. So if we go through, let's just say, make circle A, make CA. We're just going to kind of ignore that this one's extended. I don't really like that. I don't think that's necessary. That is how we make rhombuses, and it would imply that this. Maybe it implied that this line was made, this ray was made first, and then it was later cut off at D by this circle A. Doesn't matter. We're going to do it this way. Make AD. So far we made this. This is too sloppy. What am I, a teacher? We made that, we made that, we made that. Now we want to make this. Yeah, this is way less sloppy. And this, yeah, very clear. Circle C, make circle D, find E. If you just have a letter by itself, it stands for a point. You don't have to write point E. You can, but just E means the point E. And then finally make CE, make DA. Conjecture. I think it's a rhombus. Actually, conjectures can be written as positive statements. You can say it is a rhombus. It is a rhombus. It is rhombus. It's still a conjecture, though, because it's not proven. It's a statement, but it's not proven. But let's try to justify it. Let's try to prove it. Circle A and circle C and D, circles C and D share a radius size, let's just say. So all radii of circles A, C, and D are congruent. All 4 sides of quadrilateral ACED are radii of one of these 3 circles. So ACED is a rhombus. Well, let's add one more logical step. So ACED has 4 congruent sides. So is rhombus. Yeah. This would be considered an informal proof. I think it's a proof, but it's just kind of thrown together. It's not very, it's like almost a rough draft of a proof. Okay. What do we see here? You can't make a B until you have this little circle. You can't have the, why is that? Well, B is on that little circle. You can't have little circle G until you have point G located. You can't have point G located until you have lines AC and EF. You can't have E and F until you have circle A and C, because they're where those two circles cross. Well, you can't find some place where two things cross if those things don't exist yet. So circle A and circle C have to be there, which means A and C need to, these points need to be located. Well, they're centers of circles with nothing special going through them except each other, which is, that just means they have to be the same size, which they are. And then little circle goes through that, but I think that happens after you find this midpoint. So, because that's possible. So let's just say that. Make AC, make circles A and C, locate E and F. Better not use a plus sign. Use an ampersand. Locate E and F. Make EF segment. Make. Oh yeah, you can't make these segments until you know where B and D is, and the B and D is based on circle G. We need to make circle G. Make circle G with radius, size, G, A. So I guess you have to locate G, where G is where AC, let's see, star, asterisk, where AC and EF intersect. Then make circle G with radius size GA. Locate B and D. And you can make AB, BC, CD, and DA, the district attorney segment. Conjecture. I think it's a square. However, I'm not immediately sure how to prove it's a square. Oh, I know. We'll use congruent triangles. Justification. ABCD is a square because it is made of 4 right triangles that are all congruent. By side angle side, 'cause both legs of all 4 triangles are radii of circle G. And they're all right, and then they're all right triangles. I already said that, they're right triangles. So you can kind of see why mathematicians develop two-column proofs, because it gets so complicated in these paragraph proofs, right? It would be better if I had everything organized line by line. Here's a piece of fact, here's a piece of fact, here's a piece of fact. But now it's all messy, but whatever. Because both radii of G, circle G. And therefore, all the hypotenuses, the lines under tension, all the hypotenuses are congruent. CPCTC. I think I forgot to say in there that ABCD is made up of these four hypotenuses, but there, I just told you, so proved it. Okay, examine the diagram, add in information, make plan for finding the value of x, follow your plan, show your work, justifying the results. Given that measure of angle C is 90 degrees. Okay, they forgot to tell us this must be 90. Typo. Use Pythagoras. The answer is 24. Use this is C. This could be A. This could be B. A squared plus B squared equals C squared. You remember that. Okay, this is more funny. This is more fun. ABC is 90. Okay, but we know that x plus 90 plus 2x equals 180, because all the angles that make a straight line add up to 180. These are not linear pairs because there's 3 of them. It's a linear triad. Let's say minus 90 minus 90. Combine like terms at the same time. X plus 2x, 3x. Boom. X equals 30. Divide both sides by 3. How's this going? Oh, I got some time. Oh no. The big mega problem. Here there be decimals. Alright, we got this. I'm gonna call it C squared. Okay. This is this triangle here. This says they're all right triangles, so that's squared, that's squared. They'll give us this whole hypotenuse. Then it'll give us this long line. Then we got to find this chunk and subtract it, so that'll give us this chunk, and then we can get that chunk with another Pythag. (64 225 equals C squared) 6. Nope. 289. Is that a square number? Hey Google, what's the square root of 289? You don't have any internet, Google? Bad Google. This is great content. Hey Google, what's the square root of 289?
The square root of 289 is 17.
Ah, so we're starting off good. So this whole thing is 17, but now 6 squared plus b squared equals 14 squared, because this is the hypotenuse of this right triangle. Oops, getting sloppy again. Boo. Ooh, do anyone know what 14 squared is? 196. Hehe. That's 36. Subtract Dolian. Okay, 160. Okay, that's not a square number, so what are you going to say about that? What's the square root of 160? Gloogle.
Square root of 160
That's what I thought.
approximately 12.65.
We'll use 12.65. Approximo. So that means this little segment is 17 minus 12.65, minus this chunk. 17 minus 12.65 equals 4.35. And the other part of that triangle, so this is the 4.35, is 6. 6 squared plus 4.35 squared equals x squared. We're finally to the hypotenuse of this guy. And the answer is approximately 7.41. All right, I got to make one more video before class starts. See you in the next one.